Okay, so in this bonus example, it's called bonus because there are some information which you have not studied yet. Okay, for example, if you look at this particular region, ya ada banyak arrow ni. This is known as distributed load, and there are special kind of calculation that you need to adopt when involving distributed load. But anyway, walaupun belum belajar lagi, but it's good information for you lah. Okay, in order for us to decide the direction of the forces, we have to convert this distributed load into a single concentrated load. So the concentrated load, based on the principle of the distribution load, would usually happen somewhere not in the middle, but if it's a triangle, it would happen like 1/3 daripada the bigger region, okay? 1/3 of the overall length of 1.5 meter. So kalau you calculate guna your calculator, 1/3 of this length is 0.5 meter. So it means the distance from A to the concentrated force converted from the distributed load would be 1 meter lah. 1.5 tolak 0.5 akan dapat 1 meter. Okay, now what is the value of the concentrated force over here? So kalau kita tengok, the distribution load ni bentuk dia triangle kan? So if I were to redraw it like this, the length is 1.5 meter and the maximum load of this distribution is 80 Newton per meter, okay? And the concentrated force is over here, so and we'll call it F. So the F value ni you boleh calculate using the area formula. So this area is a triangular area kan. So formula triangle is tengah kali tapak kali tinggi, which is tengah kali tapak dia is 1.5 meter and tinggi is the maximum height over here, which is 80 Newton per meter. So if you notice, meter dengan meter ni can cancel out, so the remaining magnitude would remain in Newton value. So use your calculator and you will get a corresponding force to be 60 Newton. Okay, so the F over here is 60 Newton. Okay, now bila kita dah convert the distributed load into a single concentrated load, the next thing is look for the reaction forces caused by the support joints. So if you look at the statement in the question, dia kata pin connected at A. So it means at the joint A is actually a pin kind of joint. So if you refer the table given to you in the lecture slide, kalau pin, dia ada dua reaction force. So let's just call this vertical force as AY, and they also have a horizontal force like this, and let's just call this force to be AX. Okay, so the second information given in the question is that there is a smooth support at B. So again, if you refer to the support reaction table, if it is a smooth support kind of joint, then the reaction force would be over here, and the direction is perpendicular to the surface, okay, 90 degree. So let's call this force over here as B. Okay, so all the support reactions are drafted in the free body diagram. We have B, we have AX, and we have AY. So they actually wanted to know what is the magnitude of all these unknown forces. So, okay, so now we can apply our equation of equilibrium. So if you are to apply systematically, I like to apply things systematically. So I know this B is sengit-bengit and I can resolve it into vertical and horizontal direction. So in horizontal direction, the arrow would be like this. Okay. So kita tahu angle kat sini 30 darjah. So if this is 30 degree, this would be 90 minus 30 degree, which is 60 degrees. Okay. So the magnitude of the force caused by force B would be B cos 60. Okay, so if we resolve it in the vertical direction or the y-axis, so the magnitude of this particular region would be B sine 60. Okay, now that's done. Okay, so if we apply equilibrium condition in x direction, so we have to include, let me use a different color. We have to include this AX, we have to include this one, and also Oh, that's all. We just have to include two magnitudes. Okay, so assuming that all the direction to the right is positive, summation of force in the x direction is 0, then ax would be positive because, then ax would be positive because the direction is to the right, and the b would be negative. So minus b cos 60 equals to 0. We still cannot solve this equation yet, okay, because there are two unknowns or two variables. So let's just rename this equation as equation 1. Okay, now let us solve for y direction pula. Okay, if I were to highlight it with different color, I have to include this magnitude, and also this magnitude into my equation in the y direction, kan? So, assuming that upward direction as positive, summation of all the forces in y direction should be equivalent to 0. So, what's there in y direction? So, there's b sine 60. It's pointed downward, so it will be negative b sine 60. And then there's ay, because it's pointed upward, it become positive ay. And then this f is pointed downward, so it become negative 60. And all this summation would equate to 0. So if we rearrange this equation so that all the unknown variables are left on the left side, so yang tinggal adalah b sine 60 plus ay is equivalent to 60. And this would be equation 2. Okay, now we still cannot solve this particular problem yet because there are still 3 unknown variables in our equation. So, kita just extend this into applying equilibrium condition for moment. So, let's say if I want so banyak point dekat A ni kan, banyak forces acting at A. So usually we would apply the calculation of moment at this point, the point where there are many forces acting on it, because we can simplify the equation and cancel out many magnitudes. Okay, so now assuming counterclockwise as positive, so all the summation of moment acting at point A would be equivalent to kosong. Okay, so first we calculate from the B. Kita tahu B ni is 90 degree over here kan. So instead of using B cos 60 or B sin 60, kita terus pakai the magnitude of B. Okay, please recall that the formula for moment M is equals to FD. So the F in this case, the first force is B. B is still unknown, and the perpendicular distance from line of force B sampai rotation point A is 0.75 meter. Okay, cool. Is it positive or negative? So if you draw an imaginary circle around point A, it will create a counterclockwise motion. So the magnitude of this expression would be positive. Okay. Okay. Now what else? The AX, it passed through the rotation point. So we actually cancel out this AX. AY also passed through the rotation point, so we can cancel out this part. So the F ada value kan? Okay, so the F is 60 Newton. So 60 Newton, and the perpendicular distance to the rotation point, okay, already calculated, is 1 meter. Okay, if you draw an imaginary line, imaginary circle along the rotation point A, you will create a clockwise kind of direction. So the magnitude is negative. Okay, ada lagi tak? Ada. Jangan lupa this small part over here. They already given that there is another additional moment acting on this particular member with the magnitude of 90 Newton meter. So kita just masukkan je 90 Newton meter over here. It's already in moment punya magnitude, so we don't have to multiply with anything. Kalau tengok direction dia move ni, rotation direction dia is clockwise, so it would be negative because it's clockwise. So all this summation would be equivalent to 0. Oh, okay, so there's only one unknown over here. We can actually solve for B. So B, if you rearrange the equation and calculate the magnitude using your calculator, you will get a value of 200 Newton. Cool. So the direction is downward. So betul lah, okay? So this is your force at point B. Okay, now we know B is 200 Newton. We can apply B in either equation 1 or equation 2. So let's say if I were to apply B equals to 200 Newton in equation 1, okay, so I can find AX which is equivalent to B cos 60. So kita just letak terus B is 200 Newton cos 60 and I will get a corresponding magnitude of 100 Newton. Kalau positive, it means that our assumption is actually to the right. Okay. Now, how about AY? Of course, accordingly, we can also apply the value B equals to 200 Newton in equation 2 so that we can solve for AY. So AY would be equivalent to 60 minus B sin 60 or minus negative B. B tadi 200 dah kira sin 60. Okay. And you will get a corresponding value of 233.2051. Unit is in Newton. Direction is upward. So it means that our assumed initial presumption is correct. Okay. So this is how you solve for this type of question. Dah siap. Okay, now let's look at the second example. Even though the second example looks macam a bit complicated with so many wires connected here and there, but the problem is really simple. So given in the question that this is actually an electrical transformer and it have a weight of 1500 Newton acting at the center of gravity. It is supported by a pin at A. So you know this A point is a pin and a smooth pad at B. So you just refer the support reaction force for pin and smooth pad, and the first step that you always need to do is to draw the free body diagram. Okay, remember when you draw a free body diagram, there may be an additional point or additional marks will be given to you. So what is the item that we want to study? So the item we want to study is this electrical transformer. So we free up this electrical transformer from the punya tiang-tiang tu and we'll just redraw it over here. Okay, so we know it have a weight of 1500 Newton acting at the G. So let's just call this weight of 1500 Newton acting downward at the G point. Okay, and the point G is supported by pin at A. So this is point A. So if you refer to the support reaction table, if it is a pin, then there are two forces acting on the horizontal side. So I'm going to call this AX, and also on the vertical direction, and I'm going to call this AY. Okay, at this point, the direction is not important. It is just our initial assumption. Okay, and then there is also another support point at point B. So if this is my point B, dia kata it is a smooth pad. So if you refer to the support reaction table, the smooth pad, the direction is only 1, which is perpendicular to the surface of the body. Okay, so I'm going to call this B je lah. Sebab dia ada satu force je pun kan. So the question asks you to determine the horizontal and vertical component of reaction at pin A. So what is AX, what is AY, and also the reaction at pad B. So they want to know what is the value of P as well. So basically this is your free body diagram. So now the next step in solving for this kind of problem, if of course consider the body is in equilibrium. So you can write a statement like this: in equilibrium. Okay, I like to solve it step by step. So the first step is to consider the rightward direction as positive, and summation of all the forces in x direction would be equal to 0. So what are the forces exist in x direction? Okay, so there's AX over here and also there's B over here. So I'll just rewrite these two expressions in my equation. So AX, it's positive because it's to the right, plus with B is equivalent to 0. So we cannot solve it because both variables are unknown. So I'll just rename this equation to be equation 1. Okay, now the second step, sebab tak boleh solve in the x direction, we try to solve it in the y direction pula. So in the y direction, assuming the upward direction to be positive and summation of all the forces in y to be 0. Okay, so then let's choose all the forces exist in y direction. So that is this AY over here in Y direction, and this is 1500 Newton acting at G point, which is in Y direction as well. So I'm going to write this in my Y expression, whereby AY is negative AY because it's pointed downward, and the 1500 Newton is also negative 1500 Newton, and all this should sum up to 0. So there's only one unknown or one variable, which is the AY. So I can just rearrange this equation. So my AY would be negative 1500 Newton. Now you see the magnitude of the force in Y direction, we calculate it to be negative 1500 Newton. What does it mean? It means that the initial assumption is in the opposite direction. So we can also rewrite this expression as 1500 Newton, and the direction of AY should be upward. Itu maksudnya. Okay? So why is it upward? Because our initial assumption is downward, but the magnitude that we calculate is negative. So it means the actual direction is in the opposite direction to the initial assumption. Okay, as simple as that. Okay, now we still have two unknowns, which is the AX and AB. So we cannot solve it lagi. So if we cannot solve it in the X direction, we cannot solve it in the Y direction. So we try to solve it using the moment equation. So kalau you tengok dekat sini, there are 3 points. Point A, point B, point G. So point dekat mana yang paling banyak forces acting on it? So that the tips is, if point tu paling banyak force, you choose the moment at that particular point. In this case, it will be point A. Okay, so that we can cancel out many forces over here. That's the tips in solving equilibrium condition for moment. Okay, now if you want to solve in moment, assuming, dia jadi highlighter pula. Okay, if you want to solve in moment, assuming that counterclockwise direction is positive, then summation of all the moment at point, mana tadi kita nak ambil? Point A kan? Because ada banyak force kat sini. Point A would be equivalent to 0. So, now we have to convert all these forces into equivalent moment. So, recall balik, moment sama dengan FD. That's the fundamental equation lah. So, kalau kita nak ambil for the first one, which is B over here. So, B is the F multiplied with the perpendicular distance to the rotation point. So, kalau you tengok at the original figure, this distance is 0.9 meter. So, you just masukkan dalam your equation 0.9 meter. So, what is the direction? So, if you draw an imaginary circle around rotation point A, it is in counterclockwise direction. So, the magnitude of your B is actually positive. Okay, now apa lagi? There's another force over here, which is 1500. So, I'll just rewrite it, 1500 Newton. And the distance, the perpendicular distance to A is over here. So, tengok dekat figure, perpendicular distance is 0.45 meter. So, I'll just put 0.45 meter over here. Okay, now what is the direction of this moment? So, if you draw an imaginary circle around A, follow the 1500 Newton direction ni, you will get a clockwise direction. So, if it is clockwise direction, it will be negative. So, ada lagi tak? AX ni boleh kira ke? AX ni, the line of force is passing through the rotation point. So, there's no moment acting over here. Similar with AY, it passes through the rotation point A. So, tak ada distance, meaning there's no moment caused by this AY at point A. So, that's all. So, we can total up our equation to 0. So, there is only one variable over here, which is variable B. So, you can solve it simply. Bawa 1500 Newton dengan 0.45 ni ke kanan and divide with 0.9. You will get a corresponding value of 750 Newton. So, what does it mean? Positive, it means our initial assumption, the direction of our initial assumption is correct, which is to the right. Okay? So, you got the B value. So, now you have the B value. You can substitute or put the B value of 750 Newton into equation number 1. So, you can solve for AX. whereby AX is equivalent to negative B, and we know that B is 750. So our AX is negative 750 Newton. What does it mean? Okay, our initial assumption for AX is to the right. Tapi sebab the magnitude that we get is negative, it means that the actual direction of AX is actually to the opposite side, which is to the left. Okay, so that's simply it. It's quite simple. Okay, so don't forget when solving for this kind of question, draw the free body diagram. Very, 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 very important. And try to solve all the condition in equilibrium in X, in Y, and if you still cannot solve it, try to solve it in the direction of moment. Okay, that's all.